toolkit. So the factoring flowchart looks like this. This is what you want out. It's what you need to internalize the process to factor in properly.
We can get some.
Yes. Okay, so look at this first question here. Can this question be a common factor? Can we reduce it before we start anything else?
Yeah, no.
2, 11, and 6. So Patrick said no, we cannot reduce it. Is it a trinomial?
Yes.
Yes. Does A equal 1? No. So we have to do the A times C method. And we just land it right here. Okay? But now we have to know the A times C method. Okay, good. 2 times -6 is -12. Well, they're actually going to go into their class in a minute. So let's see. Bear with it for a few minutes, guys. What am I doing with -12? Multiply -12
and add to that.
and add to -11.
-6 and 4.
-12 times. -12 and +1. So -12 times +1 is -12, and -12 plus 1 is -11. What am I doing with these numbers? Good, I'm gonna put them in for X. Actually, then you can close the door until I go in and I will shut it. Thank you. Thank you very much. Okay, so I'm splitting the -11x into -12x. And I'm gonna write the 1, you don't have to write 1 if you don't want. I'm gonna make it 4 terms. Why?
It's easier. Like
what am I doing next?
In brackets, put 2x and -12x in a bracket, -1x and -6.
Good, you're gonna now pair them up. And what am I doing with the first bracket?
Yeah, divided by 2.
2 and?
X.
Good.
Then in the other bracket, you're dividing it by 1.
1. If you can't divide anything out, it does have to be divided by a 1.
Yeah. But wouldn't like be the same numbers though?
Exactly. Okay, so we take 2x out of this first bracket, so I'm just focusing on this. What does 2x squared minus 12x become?
2x. No, 2.
Nathaniel. It's division though.
-6. 6.
Yep. And what about here? X. So x minus 6. And I'm taking out a +1 from here. What does that bracket?
X minus 6.
Okay, good. What's my final factored form?
X minus y equals x minus 6 in one bracket and 2x plus 1 in the other bracket.
So you take out the common bracket, the x minus 6.
Yeah.
Okay, and then that and that go in your second bracket.
So it's
2x plus 1.
What is this called again? What is this called?
Factoring. Factor by grouping, or the A times C method. There's one thing that we need to add here though, because the question says, what are the x-intercepts? So we just factored it, and we know that factored form is our x-intercepts. But now we have to figure out where do those x-intercepts actually exist on the graph.
Is it x and 2x?
You're on the right track. What are you thinking, Patrick? This was actually a bit of a trick question, so tell me what you know to this point.
Because it said x.
Yeah. Good. So you know something about this and something about that, right? Kara, what else are you thinking?
What do you divide 2x with?
Oh, yes. Okay, let me show you on the graph on Desmos where these actually exist. And then I want you guys to tell me where the numbers come from, because it's a little bit different from what we've done in the past. So I'm going to just hop over to Desmos, which I don't have open yet. Hold on 1 second. Okay. Okay, I'm going to put in your original equation. Y equals 2x squared. Thank you. And we're going to focus on the x-intercepts. So this and that.
Yeah, same divide.
Where did these numbers come from? Look at your factor form and look at those two x-intercepts. How do they relate? Start with this one. Where did the 6 come from?
From the C value.
The x minus 6. So when we pull that out, we switch the sign of it. So the x minus 6 tells me that at positive 6 is an x-intercept. Where did the negative half come from?
We divided x by 1. I don't know, you divided x by something.
Yeah. Ava, what do you think? Yes, why 2 though? Where'd the 2 come from, Ava? Yeah, from right here. So I'm going to show you guys a shortcut, but let me show you where those numbers came from algebraically, because I'm going to show you a shortcut, okay? When you're on the x-axis, so imagine it's the ground, what's your y value on the x-axis? 0, exactly. So if I went back to Desmond's, all of my x-intercepts have a y value of 0, okay? So in essence, what we were doing, you don't have to write this down, but if you want to, you can. We were solving for the x values when y is 0. So how did I isolate for that x? When I get rid of that? I get rid of a minus 6. Added. So we added the 6 over here, and we got an x value of 6. Oops. That one was easy, okay? But look at this one here. Because that 2 gets a little bit tricky. So if I algebraically solve for this, how would I isolate for x? First, what'd you do, Summer? Did you say minus? Yeah, okay, so I subtract the 1 over here. And then what did you say? And then divide by 2. So what's this x-intercept? Negative half, which we just saw on the graph, right? I don't expect you guys to do the algebra like this every time, but you can. You're solving for the 2 x values when y is 0. So you could quickly do the algebra there. Instead, what I want you to do, this is a shortcut. You look at the r or the s value, the numbers right here at the end of your brackets. You look at this value, you switch the sign of it, so negative 6 here becomes positive 6. Divide off whatever's in front of x. So it's positive 6 divided by 1. Okay, yeah, sorry, I'm really blanking. Okay, this one, I'm going to take out the 1, switch the sign of it, so it becomes negative 1 divided by 2, which becomes this value right here. So you guys know algebra, you can quickly switch that around in your head if you like, or you can solve it like this. But we're going to go the 1 step further and not just stop at factoring. We're actually going to figure out the x-intercept with this one last step here. Questions on how I got those 2 numbers?
Is that going to be on the test?
Yes, the whole test is on factoring and finding the x-intercepts.
No, like
Any questions on that down there? This is the hard part, the factoring. This algebra hopefully is just pulling from grade 9. Okay? Yeah.
Well, you get 0 plus 6.
I moved the 6 over there.
So x equals 6.
So I just isolated for x.
It's an actual 1.
Yeah, exactly. That's what I'm
There is a 1 in front of x
Yes, the 1 is 0.
because you're finding the x value when you're on the y-axis. When you're on the y-axis, x is 0. Yeah.
I'm not saying
Okay, we're going to do one more, the top right one. We're going to try to factor and find the x-intercepts. Okay? Have to give me a green light when you're good with that one. Give me a green light when you're done with that. You're done?
Yeah.
Okay, look at your second one here. Factoring flow chart. Can I reduce that? Can I go and factor it?
No.
Is it a trinomial?
Yeah.
Does A equal 1?
Yeah.
Okay, so I should be able to do the quick method. You don't have to worry about doing A times C, but it can if I want to. What's the quick method? How do I try to break that into brackets?
Oh, yeah. I like the long.
Don't you,
Or do the long method.
The long
don't you
method.
don't you just square -9 and square 2 and then square x?
Only if it was a perfect square trinomial. This one is not. It's funny, I was just doing the long method. It is the normal. The great tends to forget the quick method. If you want to remember. Okay. I have to get on the same wavelength here for a second. So you're remembering, you should be able to just go like this, right? You're like, okay, this and that. What else was in there though? Say that again, Malcolm? Oh, I haven't done anything with it yet, because what are we doing, Kira? Yeah, well, factors of -9 give you +2. Okay, 3 times 3, and because it's negative, it has to be plus and a minus. What else?
2.
Yeah, 9 and 1. Does this, do any of those work? Okay, because this one is not possible to be factored. Now there's a couple of options here. How come this could possibly be not factorable? What are my options? Okay, wait. If it has no x-intercepts, so it never crosses the x-axis, there's one other reason why we might not be able to factor it.
There's nothing plus.
Because the factors may actually be fractions or decimals. We don't want to do that to ourselves, right? We don't want to think about what's 9 divided by 4.25, and what's 9 divided by 4.27, and go through all the decimals. We don't want to do that. So what I'm going to show you today is what happens in a scenario where there are x-intercepts, but I can't factor it. What do I do then? That's where the quadratic formula comes into play. So this is the name of this formula here is called the quadratic formula. And it is a matter of just plugging numbers in, grabbing your calculator and chugging away. You will need to know how to factor and use the quadratic formula on this test. Those are really the two skills this test is assessing your mastery of. Sure. I will give you this equation. Yes.
But actually equals -3 plus that.
Yeah, so you don't memorize this. Every time I look at the quadratic formula, I learned it to the tune of Pop Goes the Weasel. X equals -b plus and minus square root b squared minus 4ac all over 2a. But then I realized nobody knows Pop Goes the Weasel anymore, so it doesn't help you. So I'll just give you the formula. You don't have to say it in your head. Where do you think the A, B, and C numbers come from for this formula?
Wait, what is this formula?
Well, that's what we're going to say. Where do you think I get the values for the formula from?
Oh,
Yeah, specifically where?
the y equals x squared plus 2x.
Straight from standard form. So A is always in front of x squared, B is always in front of x, C is always by itself. Okay? What is my A value? This is the thing we just tried to factor and we couldn't.
Ax squared.
So let's see what happens when we use quadratic formula. What is your A value? I'm going like this, 1. It's the number right here. What is your B value? 2. What's your C value? Good. Take the sign with it and do not take the x's. Only the A, B, and C values, okay? Follow with me on this first question. I can anticipate already what you're going to ask me because I can read your mind, but just wait till the end and I will show you how to solve this equation. Okay, x equals -b. What's b?
2.
2. So -b, so -2. Plus and minus. Don't ask right now, I will explain it in a second. Square root of b squared, which is 2 squared, minus 4 is part of your equation, times a, which is 1, times c, which is -9. All over, this is why I actually like Pop Goes the Weasel, the whole thing, all over 2a. So please make sure you write it appropriately. All of that whole top thing has to then be divided by 2a at the end. Okay?
Wait, so how would you put the plus and negative.
Yeah, that's a good question. Okay, before we go any further, the only thing I want you guys to do right now on your calculator is what is 2 squared minus 4 times 1 times negative 9? I want you just to tell me what's underneath here. I don't want you to do anything else yet. Just calculate this part under here, under the square root sign. 2 squared minus 4 times 1 times negative 9.
Times negative 9?
Yeah. Most of this formula is actually going to just be getting used to your calculator. Okay? I also just got 40. So check to see if you guys can do that on your calculator. Okay, now the question is, how do you do plus and minus? We don't have a button that looks like that on your calculator. How many x-intercepts do parabolas typically have? 2. So what you're going to do is you're actually going to do this formula twice. One is going to have the plus and one is going to have the minus. So I'm going to split it. I'm going to do negative 2 plus the square root of 40 over 2. And then I'm going to do negative 2 minus the square root of 40 over 2. So what? Just split the plus and minus. And on your calculator, you're going to do 2 calculations. If you have a calculator like mine, you're going to do the negative 2 plus square root of 40 over 2 with the fraction button. Once you hit equals, then go back with the left arrow button and just change the plus to the minus, and then hit equals again. Some of you have to redo the whole thing depending on what kind of calculator you have. You're going to get a weird answer if you have a calculator like mine, so then just hit the S to D button and turn it to decimal. When I want you to grab a calculator, try this. Patrick, I want you to try this. Come to the test, if you guys don't know how to use your calculator, this formula, which should be easy, is going to sink you. Grab your calculator and plug the numbers in and see if you get the same thing as us. Who has the plus number? What'd you get?
2.16.
2.16. 22776. Here's that one more time. I mean 2.16.
Wait, what's that?
2.16. Same? Okay. With this, guys, just give me 2 decimal places. Okay? So this is one of my x-intercepts. Well, it's no wonder why I couldn't factor it, because we're not going to think about that number, right, in our factoring flowchart. If you have this kind of a calculator where it shows you the whole formula on your screen, just go back into your equation and turn the plus into a minus and hit equals again. If you don't have the arrow, you're going to have to put the whole thing in again. What are you getting?
You just get the negative.
I got negative 4.
Yeah, so I got negative 4.16 as well. Those are your x-intercepts. You're actually done.
You're done.
That's it.
Oh,
If you wanted to verify that it works, you guys could multiply 2.16 times negative 4.16. You're going to end up with negative 9 or close to it with rounding. Negative 9. And if you add them together, what is 2.16 plus negative 4.16? You get your 2 value back out. So you can actually kind of verify that those work, but we're not going to factor something like that.
So we have, can you scroll up?
That actually is the top.
No, that.
Do you have your lesson workbook? Nothing? Thank you. Hold on, because I have one. It's all in your lesson workbook. Okay, I can read your minds, and yes, you still do have to know how to factor. Yes, I will ask you to still factor. but there will be some questions where it's a word problem and it just says when is the projectile going to land on the ground? I don't care if you guys just do all those like quadratic formula, but some of the questions you will have to factor. And you do have to know both because not all quadratic equations are factorable. So then you have to use the quadratic formula. Right? Let's try this one. I'm not even going to try to see if that's factorable at this point. You could check. This would be A times C method. So kind of a long method if it worked. I don't know if there are factors of negative 50 that give you 8. We're just going to right away jump into quadratic formula today.
So that formula, the negative b, whatever, that only works for factoring.
That works to tell you your x-intercepts, if there are x-intercepts.
So will the question say, again, will the question say,
I'll say solve the find the x-intercepts by using quadratic formula.
ultimately we just know that.
Then you can just grab that formula and use it. Yeah.
So how many of those questions?
I think there's like 4
Should be like
actually.
page kind of thing?
Yeah.
Word question.
On quadratic formula. Okay, what's your A, B, and C for this one, guys? Matthew?
Your A would be 5, your B would be 8, and then your C would be negative 10.
Good. Okay, then you just grab your formula. Now just tell me exactly what this is going to look like, plug in numbers.
Okay, so it would be negative 5 plus
One is negative B, no?
or sorry, negative or positive 8 plus subtract the square root 8 squared.
Okay, then just one question, one quick thing here, Matthew. That will be a negative 8, because negative B is part of your formula.
Wait, what? Oh, okay.
Yeah.
It's just negative and then plus
Okay.
minus.
Yeah.
Then B, then be negative 8 squared.
So just 8 squared, that's the only one with a negative sign in it?
Oh, so you don't bring that over?
No.
Okay, and then it's subtract
Yeah.
would be C, negative 10 A and C.
That's minus 4AC.
So would the 4 be a part of the formula?
Yeah.
You have to move forward.
Yes. You're only substituting in A, B, and C values.
Okay, so the negative 4 is stayed. I thought that was just there.
That's part of your formula.
And then the negative B. So if B is already negative, it won't matter.
That becomes positive.
The sign becomes positive.
Yeah.
For both signs, or just on one side.
Just the B, that's the negative B here in the front. So then you want to simplify 8 squared minus 4 times 5 times 10. 264. All right, and 2 times 5 is 10. So let's split this. Negative 8 plus 2 square root of 264 all over 10, and then minus. What are you getting for the plus?
0.2.
Good.
So do you square root 264?
Yeah.
So then how did you get different answers for, because you subtract them?
What did we get for the minus?
Negative 2.
Good, negative 2.42. As with the quadratic formula, we don't switch the signs. If we're trying to find the x-intercepts, those end values are the x-intercepts. I'll grab decimals here in a second, but you'll see on the graph it is exactly positive 0.82 and negative 2.42. So on the quadratic formula, I don't switch the signs or anything. Those are the x-intercepts. In factored form, though, you would switch the signs if you were going to state the x-intercepts. So in that one, we just had 5, 8 out of 10. You guys can see here on the graph, you have negative 4.6
sorry, negative 2.42 and 0.82. Okay, so don't switch the signs of them if you're using the quadratic formula. Okay. Yeah, 2 decimals. Okay, now we've talked about this. Do all parabolas have 2 x-intercepts? No. What are the 3 different options for the number of x-intercepts a parabola can have? So we know it can have 2 if it looks something like this, right? 1 there, 1 there. What are my other options? Summer. Like this? Yeah. So actually a parabola cannot go sideways. If you want to pick smiley face or frowny face. So that won't be an option. What else? Parabola can have 2 x-intercepts. Kira? Oh, interesting. It can sit right on the x-axis. So how many would it have then?
0.
1. And that x-intercept would also be the vertex. There's one more scenario, and I feel like somebody's already said it today. Ava. Yeah, if it doesn't cross the x-axis, so if it's opening down and it's below the x-axis or opening up and above it, it will never cross. So your 3 scenarios are that it will have 2 x-intercepts, 1 x-intercept, or no x-intercepts.
Okay, what's on this?
Right, not in this format, but I'm going to show you that yes, there is. So we have 2.
So we'll be asking for the multiple choice. What are the different scenarios?
Actually, it might show up in the multiple choice.
Well, I forgot about multiple choice. I mean,
So there's 3 ways, right?
Yeah.
so 1 and 2, so 2, 1, and none, right?
Yes. One quick way to determine how many x-intercepts a parabola has is just by looking at the value underneath the square root sign. It has a name, it's called the discriminant, so you don't need to know that. But the b squared minus 4ac underneath the square root sign actually is a quick way of figuring out how many x-intercepts they might have. And this looks really if you do just the value underneath the square root sign, and you get a value less than 0, which means a negative number. It's looking a little better. Hold on 1 second.
What is your default stuff you need to
It's right at the end, but Patrick, we're not focusing on that right now. You're jumping ahead of this lesson into something else. I don't know why this looks so weird. If you guys look at your package, hopefully it looks a little bit better. If you have underneath the discriminant and it's less than 0, which means a negative number, I want you guys to try on your calculator right now the square root of any negative number. So let's say square root of negative 7. What does your calculator tell you? Exactly. If it's less than 1, so if it's a negative number, this means no real roots or no, okay, so I don't know why mathematicians decided to do this, but x-intercepts can be called roots, solutions, zeros, or x-intercepts. Put this in your sheet, please. So x-intercepts can also be called roots, solutions, I know, or zeros. It's literally all the same thing.
So then why would we have any of those, right?
No, why it doesn't have any of those things.
So why?
It is the y-intercept. I don't know why the x-intercept has so many different options. If you're under the discriminant is a negative number, you won't be able to use the quadratic formula, and it means it doesn't cross the x-axis. Okay, so you'll just say no real roots or just no x-intercepts. You'll just be done. You'll stop. If underneath the square root sign equals 0, that's what this is supposed to say, you'll have 1 x-intercept, and it will be the vertex. So if all of that, the b squared minus 4ac equals 0, it will have 1 x-intercept.
Then if it has, if it's positive, over 0 it has 2.
Yes. Most of the time, though, it in the question, that's how you're just gonna make sure your answer makes sense. You will just grab the quadratic formula, plug numbers in and start solving. And you'll quickly realize with the negative number underneath your square root sign, your calculator is gonna say that is an error. Or some calculators will say no real roots on them. Then you'll be like, oh yeah, I forgot, that's because this is a negative number. Or if you get 0 here, when you split plus and minus, you'll get the exact same value. You'll get like x equals 2 and x equals 2. It just means there's only one point. Most of the time, though, we have 2. That's the usual scenario there.
Wait, so, what number would determine it? If it has multiple, or if it has 2 x intercepts?
Just the b squared minus 4ac, just this part of the formula. Watch this, Matthew. We're gonna do one here. Okay, this is actually in standard form. We're gonna see how many x intercepts this parabola has. What's my a value? 3. What's my b value?
4.
There is no b value, so here, what's my b value?
0.
0. What's my c value? 4. Please read the question carefully.
How is there no?
The b has to be with x, and I have no x's in there.
So I just plug it into the formula that you gave.
Okay, Kira is already analyzing this. Trying to make some guesses. Let's see what's gonna happen here. X equals negative b, negative 0, plus minus the square root of b squared, which is 0 squared, minus 4ac, all over 2a.
0 squared minus 4.
So without trying to guess anything, if you just start using your formula, 0 squared is 0, minus 4 times 3 times 4. What do we get underneath here? What do you guys get right here? The thing. Negative 48. Okay, so let's say we didn't notice there's a negative under there. That's going to be weird to work with. And we kept trying to solve this. Put into your calculator 0 plus the square root of negative 48 divided by 6. What are you going to get? Syntax error.
Again.
So what's your end
0.
conclusion to this, the x-intercepts for this problem?
Is it all x?
It has none.
So I'm done with it. If I get syntax error after doing 0 plus negative 48, I'm done.
You're done. Okay, now Kira said she could tell something about this vertex and she could tell something about this parabola. I'm going to try to connect it to chapter 4. I said this is in standard form. Right here. What did I change anything if I do that right there? Did I change the equation?
No.
Okay, I just put in a 0. So if I do this, it actually looks like vertex form. Where's my vertex?
0, 4.
0, 4. And which direction is this parabola opening?
Right. Oh, up.
Okay, if it has a vertex at 0, 4, and it's opening up, how many times does it cross the x-axis?
0.
It doesn't. So here, actually, when she looked at that, she was like, you said something about the vertex, right? You're like, there's something here that I can kind of see. It looks a little bit weird because it's not in an appropriate vertex form, but if we analyze it a little bit farther, you guys already knew that. But then again, the quadratic formula tells you it. Okay, so it will all end up lining up with what you already know and what you're currently learning. Okay? Right. Look at this one. How is this one different from what we've looked at in the past?
The brackets.
Yeah. What's this form in?
This form is vertex.
It's a vertex. But in order to get A, B, and C, what form does it need to be in?
Standard.
Standard. So how do we get from vertex form into standard form? FOIL and bed mass. But before we do that, let's see if we can actually already figure this out. Where is the vertex for this parabola? Close. Negative 2, 0. So the vertex of that, negative 2, 0. How many x-intercepts does this parabola have? 1. What is the x-intercept? Negative 2. Okay, so this parabola sits at negative 2, 0 and opening up. So instead of foiling and then using the quadratic formula, if we stop for a second, you guys could actually see, I already know how to do this one because of chapter 4. The vertex is at negative 2, 0, which means it's actually sitting on the x-axis. So the x-intercepts, there's only one, is at negative 2, 0.
Wait, so you only do question find that x-intercept?
Mhm.
That's
However, if we didn't notice that, what we would have to do is FOIL this, get it into standard form, and then do the quadratic formula.
So you should try to.
Right?
You should try to.
Does anybody want me to still keep going with that one? Kelsey, no, got it. Okay. This, you can start to see lots of things colliding here with what we already know about quadratic formulas, quadratic equations.
Just share my dreams.
No, sorry.
We actually will be doing some practice outside. Yeah, after break. Okay, let's try to do this question here, pulling from what we know in chapter 4 and utilizing what we now have for chapter 5. You guys have gotten very smart. Look at, like, if you just look at what's on the board here, and but if I had just written this like a month ago, you'd be like, what in the world is this read? You already know it all. Okay, what is the vertex, the axis of symmetry, and the direction of opening for that parabola? Kira. Right?
Opening down.
Opening down. And what's the axis of symmetry? The equation for the axis of symmetry. X equals positive 2. Very good. Okay, hopefully that's not too far back in your memory from chapter 4. That's just analyzing vertex form. I'm actually going to put that down here on the graph for a second, just so we can see, do we have to do more work? Are there x-intercepts? So the vertex is at 2, 3. 2, 3, and it's opening down.
Yes.
It is going to have some x-intercepts, right? Okay, so we actually have to figure that out. So we don't want to waste, yeah, there'll be 2 for sure. In order to get this into standard form, we will have to FOIL and BEDMAS. And then do either factor or quadratic formula. It's possible it's factorable, but we can see quadratic formula. Tell me how to get this into standard form. What are you gonna do? There you go, we're gonna Good, I'm actually gonna leave it right here so we can see the whole thing. David said write the bracket 2 times. The square means the bracket times itself. And then you can hear somebody say FOIL. If you write the bracket twice, that's gonna help you see the FOIL. Okay, who can help me FOIL this?
X times x.
Yeah.
Is x squared. X times negative 2, which is negative 2x.
Okay.
And it's going to be the same thing on the side.
Okay, and then what's my last number?
Plus 3.
This is times with negative.
Oh, sorry. Negative 2 times positive 4.
Good.
And plus 3.
Good. Okay, I'm gonna simplify those 2 in the middle. Some of you guys might distribute and simplify or be efficient if you need to skip steps. I'm gonna put those 2 together at negative 4x. That's my next step, guys. So I have on the board FOIL and then BEDMAS.
Subtract negative 4 and positive 4.
Yeah. distribute this in. So negative x squared. And then plus 4x. So careful with my signs here. Minus 4. And then plus 3. What's my final standard form for this one?
Y negative x squared. Oh. Can you not subtract 4x? Oh, yeah, sorry. That's negative 4 plus 3.
Yeah.
Positive 7.
This one's negative, that one's positive.
So one, sorry.
Okay, good. Okay. All of that to finally be like, oh, now I can either FOIL a factor or a quadratic formula. Are there factors of 1 that are going to give me 4?
Yes.
No.
No, 1 times 1 are my only options. Could you ever make 1 and 1 make 4? No. So this one is not factorable. So instead, I'm going to use the quadratic formula. What's your A value?
1.
Negative 1. What's your B value?
5, 4x.
Just the number of that. Yep. And what's my C value?
1.
Okay. I want you guys put this in your calculator and tell me where the x-intercepts exist.
Also, finding the number is also what you want us to do too, right? Find where it is at.
Yeah, because that says the point of x-intercepts.
So it doesn't matter if you say there's 2 x intercepts or 1 none. You just want to know the number 2.
Correct. I want to know where they are. Yeah.
Yeah. That's pretty good.
145, I think. 145. It's gonna be perfect timing. But I need you guys to figure out these x-intercepts for me.
Wait, can I just call it?
Yeah. What did you guys get under here? Did anyone do this part?
Yeah, I forgot mine.
So you still find it.
You can do that? Yeah, you can do, I have it in my, I'm just mentally 12. Thank you, Kira. Okay, find your 2 x-intercepts, because there's one last thing we need to do before our break. Where are the 2 x-intercepts? Careful the signs, that's gonna be the tricky thing.
So how much work did this question do? 6?
Well, this question?
20?
Oh, why? 3. Well, look how much you had to do with this question. You had to analyze vertex forms, then you had to FOIL, and then you had to do quadratic formula, and then there's still the graphing component.
That's so long.
It's a lot.
How many questions is this?
No, a maximum of 1.
So it's gonna be one word problem.
No, 1 like this. I didn't say 1 word problem.
This you don't get.
This is. Did anyone get the 2 x-intercepts? Can anyone confirm here it's number of 0.26?
Yeah, that's right.
Awesome. And what's the next one? Positive? 3.73.
Yeah.
I think it's right.
Matthew's done in his head, he's confirming all is good. Okay. You will not be graphing like you did in chapter 4, where you have to use your A value to figure out the shape. The question will only ever be, put the x-intercepts on the graph and your vertex and connect them. Okay, I have 3 points right now. I have the vertex and I have these 2, 0.26, so at about a quarter. So I'm actually going to estimate that. And
You want to draw 2 on the.
3.73, so I've got 3 3/4. And then you're just going to draw it. Okay, so I'm just going to go like this.
Oh, wow.
That's it. You're not going to try to figure out the A value and the pattern. You're just going to put the x-intercepts, the vertex, and done. Okay, cool. Chapter, yeah, this chapter is the most complex, Joel. Are you feeling it right now?
How many is it the same like stuff that's like the test before? Was that one question and that's it?
No, there's a couple of different factors because there's different ways of factoring. There's a couple of quadratic formulas.
It's like how many pages is this?
Okay,
It's 140.
F plus A, K naught.
you guys already know this last part, so we're actually just gonna talk through it, and then I'll take our break here. Where's the vertex of this parabola?
Positive 1, 4.
Okay, positive 1, 4,
Yes.
and it's opening which direction?
Up.
So how many x-intercepts does it have?
0.
Exactly, because it was above the x-axis opening up. Where's this one?
Positive 1, negative 4.
Okay, and opening
Up.
So how many x-intercepts?
0. What?
We said 2. Summer, because below the x-axis opening up. Where's this one?
Negative 3, positive 5.
Okay, negative 3, positive 5, and opening which way?
Down.
Down. How many x-intercepts? 2. If you guys visualize what you already know, you have it. And in this format, if they have the same signs, so if it's above the x-axis and opening up, it has 0 x-intercepts. If it's below the x-axis and opening up, so opposite signs, they will have 2 x-intercepts. So if they have opposite signs, so this one's above and opening down, it's gonna have 2. But if it's below and opening down, it's gonna have 0. What if K was 0? We just did one of these in our examples. It's gonna have 1. Because it's sitting right on the x-axis. So your end conclusion is if the A and K have opposite signs, there's 2 x-intercepts. If they have the same sign, there's no x-intercepts. And if ever K is 0, it has 1, because we're sitting right on the x-axis. You don't need it in a chart form though. You guys already have that in your head. So just picture it or sketch it. Either one is fine to come up with some conclusions about the number of x-intercepts. Okay, we are going to